Okay, so I guess I'm audible. So hello everyone. Today in this video, yeah. So today in this video, I'm going to discuss this D problem of Atcoder educational DP contest, right? So without wasting much time, let's get started with the problem. So in this problem, we are having n items which are numbered from 1 to n. Okay, and for each I from 1 to n, item I is having some weight wi and some value vi. Okay. Taro is a guy who is decided. Taro has decided to choose some of n items and carry them home in a knapsack. So basically, knapsack is a kind of bag which is having max capacity of W weight, and which means that the sum of items he is choosing, uh, some of some of the weights of item taken must be at most W. Okay, so basically it is saying, let's say we are having some n items, one, two, three, four goes on up till n. Let's say these are the weights and these are some values for these items, and let's say Taro is choosing this and let's say some this item. So W2 plus W4, so on, all these items which are being chosen by Taro, the total weight should be less than equal to capital W. This is what the condition of knapsack is given to us. Okay, and we need to maximize the sum of values that Taro can take to the home. Okay, okay. So the first thing, this problem is this can't be done using greedy approach. We can like, if you think that it can be done using greedy approach, you can check for the test cases. I have already done that part. That's why I'm saying that this is not a greedy problem. So let's try for the DP approach. These are the values for these are the constraints for this problem. Let's try. Okay, so let's try for form 1. Let's see if it is a form 1 or not. As you can already see that we are having a array of size n, and from that array we need to like we need to consider a subsequence such that that subsequence is having total weight less than equal to capital W, and we need to maximize the sum of values of that subsequence. And I have already discussed in previous video that whenever you see a subsequence kind of a situation where you need to consider the decision making where you have to take that index value or not, in this type of situation we generally use form 1. Let's say, so let's quickly write the steps of doing DP problems. First step is identify form, which we have already identified that this is form 1 problem. Second step is DP state, formulate DP state. So let's try. The the key point that we should keep in mind whenever we do a DP problem, we must take all the values which are given in the problem as a constraint inside a DP state, and the required output, let's say, which we have to, like in this problem we have to maximize the sum of values. So this maximum sum of values should be the output of DP state, whereas we need to make sure that the total sum of weight should be less than equal to capital W. So we need to make sure that the total sum of weights should be inside our DP state. Let's try to form a DP state now. Yeah, DP of index comma. So basically, let's say is the general DP, like general picture of this problem. Let's say we are at this index and we need to make decision whether to take this index or not inside our subsequence. But before taking or not taking this, we need to make sure that we need to consider the total weight which we have already considered in this part, right? So which let's say W taken, we need to take this part inside our DP state. So if this is a DP states, let's quickly assign a meaning to this. uh, yeah, and it is easier step. Let's say DP of index comma W taken, we can easily formulate DP state. So Let's quickly see the question statement. We need to maximize the possible sum of values. Okay. So this DP state should return the maximum sum of values that Taro can achieve in array of index to last, such that W taken weight has been already taken is already taken. Let's say this is the DP state. Okay, so we are done with the step 1 and step 2. Let's quickly go to the step 3 part. Yeah, yeah. Which is step 3 is right transition. Okay, so yeah. So if DP of level comma not level sorry DP of yeah DP of index comma W taken, and we need to make consider two situations where we are considering this index or not. So first situation, let's say we are not taking this index, not take. If we are not taking this index, the output should be dp of index plus 1. But if we have all not considered this index, so the w taken should be as it is, and there will not be any contribution in sum of values. If we are taking this dp of firstly, it will contribute in the it will give me a contribution of value of that index plus, because I have already taken this index now. dp of I need to make handle dp of index plus 1. Now the weight taken is already should also be increased by weight of this index. Weight taken is weight of this index. These are the two transitions, and we need to consider the maximum out of this. So we will take max out of both these transition steps. So we are done with transition step also. Let's quickly go to the fourth step, which is check for time and space complexity. Yeah. So for time complexity, we have already discussed that this formula for that is number of states time 1 plus number of transition, right? So here the number of states for the DP is as index can go from 0 to n minus 1. So there are n indexes, and weight can be up till capital W also only. So the number of states will be n cross W, and number of transition is 2 only. So the time complexity for this problem will be big of n cross W into 1 plus 2, which will be almost equals to big of n cross W, and n and W for this problem are given to us. These are 100 and 10 to the power 5, so it will not go up beyond 10 to the power 7. Big of 10 to the power 7 or max, and the space complexity will be big of n cross W only, similar. So as this is inside our bounds, so we can code this. This is a green flag for next step. So next step is quickly code this. Okay, so let's go to the coding part now. Before going coding, before going to coding part, let's quickly summarize the algorithm for this now. As we are already understood in the problem that we need to consider the subsequence. That's why I have already identified that this is a form 1, and in form 1 the basic structure of the problem is something like this, where this is the current index, and we have already taken care of this part, which is giving me some w taken, right? I need to make take this index or not take this index. Based on these two decisions, the output will be something like the dp of index plus 1, and w is same, or you can say dp of index plus 1. In case of taking this index, w will be incremented with this weight of this index, and value will be also added to the answer, and you have to take maximum out of these. Yeah, so this is up to transition part, and we have calculated the time and space complexity using the formula. Where is the formula? This is the formula for the time complexity of a dp solution, right? So now we are good to go for a coding part. Let's quickly go code this problem now. Yeah, this was the problem. Yeah, so the input format is n cross w, n and w, then w and v. Okay, n w, cn, n w, and transform. Let's create vector for weight of size n and vector for values of size n, and let's quickly take these as in input. So the input format is w comma v, c in w I comma vi. I am using zero based indexing in this problem, whereas it's in the problem itself it is given one based indexing. No problem. Yeah. Okay. So now I have taken this as input. Let's quickly create the. Okay, so I will be solving this DP solution using recursive approach. Let's quickly implement the recursion function. So, in which I am taking index as input and the weight taken, W taken, and also I need to take these as input, not as input, just I have to pass these vectors, W and V. Okay, so before going to code this, in generally we code this in recursive manner. We follow 5 steps. First is pruning, base case, because base case is always necessary for recursive code. Then cache check. I will explain you each and every step. Then compute state. Then save and return state. Okay. In base case, you know what is base case. Cache check is a step where you check for that condition of memoization whether this DP state is already solved or not. If it is already pre-calculated, we will directly use that state. If it is not pre-calculated, we will calculate this is inside this part, and after calculating, I will return the solution to that DP state, right? So for that given case, yeah, this was the DP state and transition. So the DP state is saying yeah, dp of index comma w taken is the maximum sum of values that Taro can achieve in this to this part, right? So for this for the base case of this, as we can see that dp state is progressively like I can express the dp state of index in terms of index plus 1, right? So that means for index I need the uh, values of dp state of right part, right? So yeah, before coding this, let's quickly see the base cases. If index is equals to n, index goes up till like if index is n, that means I need to consider this part n to n minus 1, which is invalid interval, right? That means I have already processed the all array. If I have already processed the array, that means this dp not contribute anything. So the dp of n comma any valid weight will be 0. Are you getting my point, right? So as yeah, so the final sub problem will be dp of 0 comma 0, because initially I am at the first index and I need to consider the whole array from 0 to n minus 1 interval, and I haven't uh, taken any kind of weight up till now. So this dp of 0 comma 0 will give me the final sub problem answer. Let's code this up. For base case, I need to check whether if index is equals to n, or you can say the w dot size, that means I have already processed the whole array, so I will return 0 in that case. Now let's go to the computational part, transition part, right? Initialize the answer value with wait, I need to max, right? So initialize with 0. I can take or not take. So first step is not take. If I am not taking this current index, so answer will be max of answer comma recursion of index plus 1, and w taken will be as it is, which I have already discussed. If I am taking this, before taking I need to check for a condition whether already the w taken plus the weight of this index, if this is less than equal to capital W, yeah, I need to pass that also. This is capital W, sorry, yeah, yeah. So I need to pass that also inside this. Yep. Huh. If this is less than equal to capital W, that means I can take this index. In that case, answer will be max of answer, comma, value of that index plus recursion of index plus 1, comma. W taken will be incremented by the weight of that index. That's all. And I have to make a DP of, I am using a global DP over here. You can use vector also, of size 100 cross 10 to the power 5. So yeah, 10, let's say 105, 1 2 3 4 5. Yeah, and I need to check, as you can see the DP state is storing the maximum sum of values, so this will never go to like this can never reach a negative value. So I am checking where if DP of index comma W taken, if it is not equals to -1, that means I have already pre-calculated this DP state, so I just have to return this DP state, right? W taken. Otherwise I need to update the DP state with this answer value and then return. Yes. Okay, so before using the DP state, let's quickly set the DP values as -1 using the meme set value. Meme set, yeah. We see out recursion of 0, comma, W, comma, V, comma, capital W. Yeah. Let's see if this code works or not. Uh, let's run the code. There is some error. Okay, I haven't passed this. Okay, which line? Line number 111. Okay, and here also I need to pass W, V, capital W. See now, it's 90 and 90 is the correct answer. Let's check for the second input. Yep. Let's check for the third sample input. It's working. It's 17. It's correct. Let's quickly submit this now. It's like one, and it got accepted. Okay. So before ending the video, let's quickly summarize the DP code. So what I have done in this DP, like in this recursive code, is I have taken index and weight taken inside my state of TP. These are just passing part. And in base case, I am checking whether if the index reaches to last index, not like if there is an array of size n and indexes are from 0 to n minus 1, and if index reaches to the n value, that means I have already processed the whole array. That means that this TP state will return me 0 because there is nothing to uh, update the sum of values, right? And in this step, I am checking whether I have already pre-calculated this TP state or not. This is just a memorization step. If this is the case, I am returning the pre-calculated DP value. Otherwise, I am calculating the DP value using this answer value. I have initialized this with 0 because I need to maximize the answer value. So this is the not taking case where I am not taking the index part, uh, the index IDX. So for answer equals to max of answer comma recursion of index plus 1. W taken will remain same because I haven't taken the index. And if while taking, I need to check whether this condition holds or not because the total weight should be less than equal to W, right? And answer equals to max of answer comma value of that index plus the next DP. But in that state, the weight taken should be changed, right? And that's how I have coded this problem. And I have already discussed this part, solved. So thanks for watching. Bye bye.